That includes the history of all the software decisions that have ever been made. It did try to break into the Pentagon, get the codes, launch all the missiles. An ability to validate video.
Version management.
I'm like, didn't I also tell you previously not to delete anything out of the data folder? Ding. So Larry Wall, who is the inventor of Perl, also the three virtues. First, we talked about is hubris. The second is impatience. If you are a good software engineer, you should be mad when things run slow.
Yeah.
You should be mad when your program compiles slowly, which is a fascinating scenario. Right now, the way I'm doing most of my development is I have an old machine. It is at least 15 years old, but 15 years ago, it was a beast. Had 6 Xeon processors and 24 gigs of RAM. Nowadays, of course, that's nothing significant. And it has, regular old SATA drives. But for a while, it was my wife's gaming machine after I brought it home from work. And so I put a fast drive in it. And now it's sitting in the basement. And what's awesome about it is my coding environment. So here from my Windows laptop, I SSH into that box and I tunnel X over SSH. So, I type code, whatever, and the code window from that box in the basement pops up on my laptop here, and I'm able to work on that. Then when I'm out in the living room, I have a different laptop out there, but I still SSH into the box, code, boom, it pops up there. And so I'm actually using the exact same environment, and that's awesome, especially as
that is great.
I've been, doing more and more agentic assistance in my coding. So now, like if I were to open up my VS Code here and start working on the project, it wouldn't know the conversations that I'd had with the AI session that's running on the VS Code in the basement. And I've sort of gotten around that a little bit in most of the projects that I work on now. One of my very first prompts is, in all the conversations that we have, let's keep a file called progress.ai, and I'd like you to log the stuff that we do in there. Log every problem that we have, how we eventually overcame it, with the idea that someday a future AI might read this and be able to take up where you left off.
Sure.
And
that's important. That is important
really
because a lot of
Mhm.
what we do as engineers, we make decisions along the way, and those decisions go into the code, right?
Exactly.
And so when you're the same engineer looking back over the code, especially if you haven't commented it particularly clearly, there's a lot of context, if we're thinking in an LLM kind of framework, that's in your brain that you have for what this business needed, what the problem was, what the user's need was. And if you don't have a way of documenting that with your LLM, and I'm glad that you're doing that, that gives the LLM the ability to, on its next pass, remember that context, why it made a certain decision. And I think without that, people are going to find a lot less success, especially using an LLM.
In many ways, it mirrors human software engineering, because we find ourselves, right? I mean, it mirrors human life, right? One of my favorite quotes is, "Those who do not know history are doomed to repeat it." That includes the history of all the software decisions that have ever been made.
Absolutely.
And so this is, I don't want to throw my team under the bus, but the Reel Report guys at one point in time, Reel Report is about having an ability to validate video.
You're the CTO there.
I am.
I've heard a lot about it. It's really cool. Tell us about it.
The long and short of it, my elevator pitch, let's say that we're on an elevator together and I have 3 floors to explain it to you. I would say, if you see a video on Reel Report, you know that it was shot by a human being at the place that it says it was shot at the time that it says it was shot. We guarantee that any video that you see on the Reel Report site is authentic.
Wow.
Ding.
Yeah, that's super important.
The elevator ends, you get off. But then Tim Cook is also on the elevator and we're going up to the 11th floor. And so now I've got a little more time and I say, the way that we do that is when your phone is recording video, we record every piece of information that we can get from every sensor on your phone. GPS data. We're in an elevator right now. It's going to show that we're accelerating. Cell tower data. If you were in a car moving down the road, we would see that the cell tower data was changing as strength of signal changed from different cell towers as we moved from one cell tower range to another. Accelerometer moving around like this. magnometer, which is the compass direction, the way the compass is facing. What we do is we use all of that metadata to validate whether or not the video is true. As an example, I
That's
could have
incredible.
you.
So you can know where you are and what you're seeing was a real representation. So somebody could potentially visit those coordinates and replay that motion and see the same things in the background and stuff like
that
that.
that part is true, but more than that, and so it's interesting because we do actually have a future development plan, which is to say, find videos that are located in the same place and use AI to confirm that this video looks like it should based on what that video looks like.
Nice.
And that's interesting. And I'll tell you, that technology it won't be new technology that we built. Microsoft built a really good thing called photosynth about 20 years ago. And they did an amazing demo of it. And let's full disclosure here. I don't like Microsoft. I was a Java engineer. Microsoft put a real concerted effort into killing Java because they didn't like the idea of write once, run anywhere software because it threatened their monopoly on whatever. Microsoft and we've been on a date recently. We're finding a way to live with each other. But Photosynth was this amazing project where they went to Flickr. People who don't know, Flickr eventually became Yahoo Photos, which, has now been surpassed by Google Photos and Instagram and everything like that. But what they did is they went to Flickr and they found all the photos that were tagged with Notre Dame. And then they put them together, and it was, Notre Dame in Paris, got to be photographed, 100,000 times a year. That's probably a conservative estimate.
Sure.
They took all of those photos, and then the Microsoft engine mapped them together and was able to make an unbelievably good 3D model inside and outside of Notre Dame. But this was like year 2000 technology.
That's really cool.
Yeah, it was amazing. So we certainly believe that we can do that with video as well and say, okay, does this video that you took looking south from 64th Street have some of the stuff that my video looking north from 63rd Street has in it? Because they should complement each other. That part's pretty sophisticated, but the simple stuff a human being ought to be able to do. Like if you as a human are watching my video and you see the compass direction and then you see the camera move like this, but the compass direction says, oh, he's still looking north. You're like, well, that's wrong. It should have gone to west. Reel Report does exactly that. In fact, I have a video that shows how the AI thinks about it. So the AI watches the video. And then based on it watching the video, it generates what it thinks the metadata would look like. It's like, this is what I think the compass direction should look like. And the AI watching the video doesn't necessarily know whether you're facing north or south or whatever. In fact, it makes an assumption that you are facing 0 degrees, which is north. And then it says, okay, now there's a 90-degree turn to the left, and then there's a 15-degree turn back to the right, and it tilts up and all that stuff. And so it makes what it thinks is a map, and then it compares that to the metadata that was collected. And that's what AI is really good at, right? We say large language models. It's models. You're modeling data and seeing how well they map. And that is, people often don't understand how old that technology is. So there's, I've mentioned the fact that I'm old. My linear algebra teacher talked about a formula called the Chebyshev economization of functions. People who have taken calculus or anywhere know that the definition of a function, it's that a line that never covers the same space twice. It always progresses from left to right because we're Americans. But whatever it is, it doesn't loop back upon itself. You can write a function to describe almost any line or something very close to it. In the old days, before GPS, the way nuclear missiles, ICBMs would guide themselves is that they had a collection of functions of what the horizon was supposed to look like based on where they were going. And they had a compass, of course, as well. And so then it would take a picture and it would draw a line and it would compare this function against that function and say, is it close enough? How do I adjust where I'm going? So, and this is, 1960s math,
Interesting.
and people are doing stuff like that, but it's really old. And that idea of saying there's a model and a computer ought to be able to use models is the basis of what AI is. And we've been sort of working towards that all this time.
Yeah, I
So
mean, not to
go
interrupt,
ahead.
that kind of goes back to what you were saying about code running quickly, or in some case, running quickly is running efficiently.
Yes.
And it's amazing to think how much junk we layer on top of the
Oh my
metal on
God.
our computer to actually get a basic task done. Like if I'm running a for loop in JavaScript, it's doing so much in the background that I'm
Yep.
not paying attention to.
Yep.
And people used to code that stuff in assembly, but there's a reason we don't use assembly, but I'll get to that.
Yep.
But it's just so inefficient. And there are ways to analyze the compiler, to analyze the code itself and figure out more efficient ways to do it. Sometimes it's worth it to make it more efficient. Sometimes it's not. Sometimes you have something else way more inefficient that you need to be working on. But in some sense, there is a reason to be using that over assembly. And part of that is what we've already discussed, the readability, the
Yep.
understandability for another engineer. And if it's going to be super difficult and you're all using assembly, but nobody else in the world uses assembly, I mean, if you're going to get acquired as a company, if you're going to, like, there's so many things you need to consider. And if you're building on a technology nobody else is using, that's going to be part of your problem too. But yeah, there's so many opportunities to take the junk that we have and kind of speed it up and get more out of it. And before I forget, there was one of the builds that we run at our day job runs in about 6 minutes. The other one runs about 4, and I think we can dial them down to get done in about 2 or 3. And it bugs me when it takes 6, man. Like,
Yeah.
because we commit the code, we wait for it to build, we tell QA there's a build going to be ready, and then they have to wait 6 minutes. They've forgotten about it by 6 minutes, you know?
Exactly. One of my favorite software blogs, I actually don't know if it's around anymore because I haven't read it in a while, but Joel on Software. And one of the things he said is like, if you're not buying your engineers the most powerful computer you can every 2 years, you are throwing money out the window because the most valuable thing you have is your engineer's time.
Yeah.
Okay. Compared to, let's just say you'd spend $2,000, $3,000 on a really hefty desktop machine.
Mm-hmm.
That's nothing compared to the at least $100,000 you're paying a software engineer.
Yeah, absolutely. Like that's such a marginal cost in the big scheme of things.
Right. And the thing is that if you start compiling your program and it takes 5 minutes, the engineer opens the internet.
Mm-hmm.
Good luck.
Yep.
They're gone. And that's just the nature of the beast. And it's true for almost anybody at this point in time. So if you can have your program compile really quickly, and it's funny. So one of the other projects I'm working on right now, tellgovernment.com, people can go there. I can't guarantee that's 100% working right now, but it's pretty close. It'll be closer on Monday. I don't know when we're going to air this either. So tellgovernment.com runs in my basement, Spring Boot backend, React front end. And I don't really know React that well.
Mm-hmm.
I mean, I can get my face slapped in JavaScript, but I'm not 100% clear on what is best practices in React and stuff like that. And one of the other things that I don't really do is differentiate well in my head when it's time to rebuild the front end. Did I actually make a change that requires a front end to change? And that's something that I really don't think about a lot because I'm from an older school where the front end was JavaScript that was served every time you got to the page. And I know you can run NPM in dev and it refreshes it all the time. So it's a live stream of that.
Sure. But before your JavaScript was making network calls for more code.
Well, actually the JavaScript was delivered with all of the data based on HTTP code.
Right.
So there was only one call and you got the entire page and all the JavaScript and all the data all at once, which it was the only way we could think of to do it at that point in time. And this is Ajax. Microsoft invents Ajax in like 2099. It becomes a big deal. IE4 is the first browser to support Ajax, the XML HTTP request call. I remember we thought to ourselves, well, this is going to change a lot. And it did. It changed a lot of stuff. So my build function, because I'm old, and so another prompt that I always give AI when I'm working is, I was born in 1967. Sometimes I use outdated technology. feel free to tell me if you think the technology I'm using is outdated. So in the beginning, I said, okay, let's make a Maven project. It's like, are you sure you want to use Maven?
That's a clever approach. Yeah.
Well, I find that AI is good at stuff like that.
Mm-hmm.
Now, the funny thing about it is we went through this twice yesterday. There's a folder called data. And a lot of what Tell Government does is data parsing, screen scraping, data parsing, to essentially find every elected official in the United States. And it used to be that Google provided that for free in the Google Civics API, but they don't anymore.
Yeah, I actually worked on a project that used the Civic API for a while, and I remember something about it being
yeah, they sunsetted it in May of this year.
Oh, wow.
But that's okay. I mean, there's an easy list of all the Congress people. It's on congress.gov. And then, finding state people and stuff like that. That's actually something that AI is pretty good at. You can just say to, a deep thinking AI, find me all the state executives and their snail mail addresses and their official photos for all 50 states. Go. Comes back. And sometimes, fucking ChatGPT yesterday was giving me a hard time where it's like, how about if I get them to you 10 at a time? I'm like, okay, you can do 10 at a time. It's like, all right, confirm to me that's what you really want. I'm like, yes.
It is so funny when you ask an LLM for something and it's like, that's going to be a little too much. And I'm like, you're a computer. You do what I say.
Well, the funny thing about it is that it said, do you want me to give them to you as a script, as a downloadable file? Mm-hmm. I'm like, no, just print them to the screen. And so it did that. And so it did it in, let's say five state executives in every state, 250 people. Some states only have 4. Some states don't have auditors or they have comptrollers. Several states don't have lieutenant governors, but we'll call it 250. And so it's got, but it's doing it 10 at a time, right? It's doing, 10 states at a time. So it's got 50, 50, 50, 50. And then afterwards I said, great, you gave me all that data. Can you concatenate it into one thing? It's like, sure. And then it's able to give me all of it at once.
Yep.
But it couldn't figure out that it could have done that and then done everything at once. So, but the other thing that's been interesting is that a lot of what I do now is, and this is I think people are going to be very unhappy to hear me say this, but I usually I use Codex, ChatGPT's Codex and VS Code as my AI agentic, and I use it in unlimited mode. No sandbox. It can do whatever the fuck it wants. It did try to break into the Pentagon, get the codes, launch all the missiles. But after we cleared up a direct prompt saying that's not okay, it kept trying to delete some of the files out of the data folder. And it's like, well, we're not using that anymore. I'm like, we're not using it right now, but just don't delete anything in the data file. And then in the data folder. And then I'm watching it, it lists all the things that it does. And I'm like, clean everything up, commit this all up, make a new version tag, put it up in GitHub. Because I have some workflows that do shit when a new version is released. That's how I run CI/CD generally. See it deleting a file out of the data folder. And I'm like, why did you delete this folder? It's like, you did tell me to clean up. I'm like, didn't I also tell you previously not to delete anything out of the data folder? And it's like, oh, yep. I'm like, go get it back from GitHub, which it did.
That's good.
Which is great.
Good. It's good that you had the forethought, well, the experience to be using a version management, because I know there's some people out there who maybe aren't doing that with their AI.
So